Okay, this is the pre-lab video for determining the percent yield of copper. And I have all the equipment you'll need for this lab laid out. We have a balance, we have the copper 2-sulfate pentahydrate, which you need 12.20 grams of, the iron filings that you need 2.24 grams of. You will need a 150 ml beaker that you're going to get the mass of, a 250 ml beaker that you do not need the mass of, 50 ml graduated cylinder, striker, glass stirring rod, scupula, beaker tongs, the ones that have the rubber coating, and then the setup for heating, the iron ring with the wire gauze and the Bunsen burner. And that's everything that we're going to need to start with. So what you want to do first is get the mass of the empty beaker, and that is the 150 milliliter beaker, not the 250 milliliter beaker. Now for this one I already massed out the copper 2-sulfate pentahydrate and iron filings. That's what it tells you on the front page. And what you want to do is take this copper 2-sulfate pentahydrate, you want to put it into the 150 milliliter beaker, and you want to add 50 milliliters of water to it. And when you do that, it's going to look something like this. Not all of that solid, that copper 2-sulfate pentahydrate, is going to dissolve. You're going to have a decent amount of it that is undissolved at the bottom. So if I stir it up, you can kind of see it sitting on the bottom. So what we have to do is heat this up to get that to dissolve. So that's why we put it over here. Now before you put the beaker up on the iron ring, make sure you check the level of the Bunsen burner flame relative to the iron ring and the wire gauze. You don't want it too low or too high. And what you want to do is start heating that up. And while you're heating it, every once in a while stir it. And what you really have to do is make sure that that solution does not boil. So one person's going to have to stay there while the other person's massing up the iron filings and stir it and keep an eye on it. Now one of the things that throws people off is sometimes you'll start seeing a little bit of bubbling, tiny little bubbles forming on the bottom, but there still might be some undissolved solid in there. So what that's telling me is that you're heating this a little too quickly. What I would do is use the beaker tongs, take it away from the Bunsen burner, stir it a little bit, give it a chance to cool off a tiny little bit, and lower the level of the flame. And then put it back up there and heat it a little more slowly. So if you start seeing bubbles forming, but they're still solid, let it cool for a minute maybe, and lower the flame, and then restart heating it again at a slower pace. But eventually that is going to dissolve. You'll have a nice clear blue solution with that. And what you want to do is add the iron filings very slowly to it, because it is going to fizz. It's going to bubble, and if you dump it all in too fast, it's going to bubble over the beaker. It's going to come out and go all over the bench top. So add this in kind of slowly. You'll see it'll fizz and bubble, and you want to stir that pretty vigorously with the glass stirring rod. And what you end up getting is something that looks like this. Now the solid on the bottom is coppered color. We're doing a single displacement reaction. But you have all this liquid in there, and you might actually have a little bit of solid sitting on the top, and we can't really do anything about that. That is really, really small stuff, and the mass of that is actually really, really low, which is why it's floating. Now at this point, we want to decant that liquid. What we end up wanting to do is take the glass stirring rod, because we don't want to mess all over the countertop, and what you could do is actually hold this all in one hand if you want, and pour it very slowly, because now the surface tension is going to cause that liquid to stick to the glass stirring rod. And we could direct that liquid where we want it to go. So now it's all going in that beaker. And what you want to do is when you decant, you pour it very, very slowly, and you want to get just the liquid into the beaker. Now that small solid that was on the surface, there's nothing we could do about that. That is going to go into the collection beaker. But the solid in the bottom, we want to stay there. So you want to pour it very slowly and leave as much solid in the bottom of the beaker as you can. And eventually what you'll have is just the solid in the bottom. And it's still going to be wet, but we have to rinse that with water. So you're going to take some deionized water, and you're going to add it and stir it up and decant it. You're going to do that 3 times. Now I didn't decant all of that liquid just to save time, but you want to rinse it 3 times and decant it slowly all 3 times with the use of the glass stirring rod. So you now just have copper in the bottom that has been washed. Now we have to let that copper dry. After the copper is dry on day 2, what you want to do is get the mass of the beaker and the copper. We know the mass of the empty beaker already, so you can figure out the mass of the copper. You're going to have to write a balanced chemical equation for this reaction, and after you do that, you're going to have to do 2 stoichiometry problems. One is you're starting with the mass of the copper 2 sulfate pentahydrate, around 12.20 grams. You're going to figure out the mass of copper that theoretically would be produced from that 12.20 grams of copper 2 sulfate pentahydrate. You're going to do the same thing for this problem, except you're going to start with the 2.24 grams of iron and figure out what is the theoretical yield of copper you would get from that mass of iron. Now what it's going to do is which product produces the least amount of copper. You're going to get 2 different answers here because one of those reactants is considered the limiting reactant. It is the one that gets used up first in the chemical reaction. And the limiting reactant is really what dictates how much product you will theoretically get. So the least amount of copper, which one gives a smaller number for these answers, that is the limiting reactant. And that is telling you how much copper you can actually make. What throws people off is when we ask, what is the most amount of copper that can be produced? It's actually the lower of these 2 numbers because a limiting reactant is going to only allow us to make a certain amount of copper. And then once you have that, you can go through the percent yield and answer the rest of the questions in the lab. And that's pretty much it for the percent yield of copper lab.